you don't think much about turning the switch on and having the lights turn on until you can't do that.
Right.
Then all of a sudden you're like, oh, this is an important part of my life.
The world of energy and the technology shaping it. I'm Josh Tate, and this is Between Two Turbines. Powered by NAES. Alan Bull, welcome to the show.
Thanks. Nice to be here, Josh.
Yeah, it's good to have you.
Yeah.
So I wanted to start with what brought you to NAES. You know, where did you start in your career, and what eventually brought you here?
It's been a somewhat interesting journey for me. I went to college to study electrical engineering. After my first 2 years in school, I took a power engineering class and loved it. And so my last 2 years, I really was focused in power engineering. I did an internship at a large coal plant in the St. Louis area. And then I also interned up in Chicago in transmission planning. And those two experiences were very different. One was in a plant, one was in a corporate setting. And when I got out of college, I wanted a job where I was more hands-on, so more like the plant type setting. Also, I loved to travel. And so I had an opportunity with GE to be a field engineer and literally travel the world with them in their global field engineering program. And so I did that for 5 years, which was very interesting. I learned a lot, but also I was on the road about 320 days a year, which was great as a younger person. But as I wanted to have a family and strengthen friendships, it became challenging. And I was working at a plant, actually our Luna plant down in Deming, New Mexico. And the plant manager there told me that he worked for this company called NAES that was based in the Seattle area. I already lived in Seattle. My wife and I wanted to stay in Seattle. And so kind of on a whim, I just went on their website and applied for a job. Interestingly, I was the first job I applied for was for a project engineering role, but the person needed to speak Spanish, which I didn't do. So I interviewed and did not get that role. And then another job opened up almost immediately thereafter as a project manager for domestic plants, and interviewed and got that job. And I've been here at NAES for almost 19 years now, and I've had lots of different roles, and recently moved into a new job for me, which is a VP of O&M services, where I lead and oversee about a third of our O&M portfolio.
Yeah, so you started kind of on the ground with GE, came here, started in the project management, and now tell me about your new role.
So as I mentioned, I am a VP of O&M services. I lead a portion of our operations directors. We have 20 operations directors here at NAES. 5 of them report to me in this new role. And the way that we align our operations directors is with our clients. When I first started at NAES, we used to try to have our project managers and the equivalent of ODs, we used to have them geographically aligned, but we realized that client alignment is more important than geographical alignment. And so one of the interesting new challenges for me in this role is that I've got our ODs that support our Mexico fleet and our Canadian fleet. And in my other jobs that I've had here at NAES, I've not had to do much international travel and much international accounting. And particularly in Mexico, there's a lot of different employee challenges that are new to me. And I have a lot to learn about that. So I'm really excited about that.
So not 320 days of traveling.
No. I don't think that would make for success at home for me.
Yeah. You know, the kids now, they're doing van life.
Yeah, that's true. That's true. I'm not that handy, but maybe I could, buy a van that's already been fitted up for it and drive across North America.
Yeah.
Because I've got plants up in northern Alberta and all the way down to near the southern
Hey,
tip of Mexico.
NAES van life.
There you go.
Throw a logo on the side.
Exactly.
Yeah.
Maybe marketing could take care of that for me.
Yeah. There you go.
Yeah.
Well,
Yeah.
I'm actually getting replaced by a robot.
Okay.
Nancy let me know last time. So
Okay.
AI is already taken over my brain, and
Right.
robots are next. So,
Exactly.
but we can figure out a van for you. NAES, I think it's not necessarily a household name, but I feel like maybe it should be. And I think energy is becoming a bigger conversation for the average consumer at the dinner table.
Mm-hmm.
Why do you think that is?
Well, you just mentioned a couple other reasons. AI is a large power consumer. So currently, AI makes up approximately 1% of the load that we have in the U.S., and that's projected to grow up to maybe 5% in the next 5 to 10 years, and that's significant growth. And so we, as a country, are becoming more and more power hungry.
And 5% to me sounds low.
Yeah,
To be honest with you, because as a marketer, I use AI a lot.
Yep.
And I perceive as the energy demand increases as we have the bandwidth, I imagine it's going to be used all over the place, and growth will continue to be exponential.
Yeah, and you're going from 1% to 5%. So it is
huge.
It's a huge growth percentage, but as an overall usage, it's true. It's relatively small. So there are other drivers. The electrification of the transportation industry, while not hasn't moved as fast as some people have predicted, that is going to continue to grow as well. And I think if we reshore manufacturing, like the administration is talking about, that's going to drive additional need for energy. So I just think that because almost everything most of us do in our daily lives requires power. From our cell phones to our air conditioners to our refrigerators and everything in between. It's just more critical day to day. And I think that people are starting to recognize that because there's been more power outages because the grid itself is more taxed and because we don't have as much generation as our load is growing. So there's a lot of challenges that we're trying to overcome. And so you don't think much about turning the switch on and having the lights turn on until you can't do that.
Right.
Then all of a sudden you're like, oh, this is an important part of my
And then
life.
where do we point the finger?
Right, exactly.
Where along the line? Where's the where does the hammer come down?
Exactly.
And there's bottlenecks, it seems like, in many layers, from the transmission lines to just needing additional power.
Yep.
And looking at the renewable energy coming on the grid, it obviously operates very differently.
Mm-hmm.
We maintaining that frequency on the grid it's complex.
Mm-hmm.
And I just wonder, where do we go from here? We need more power. Recent legislation is changing some of how this is going to play out. Where do you see things going? Yeah,
so I mean, you're kind of mentioning the big beautiful bill.
Right.
It changed some of the tax incentives that were in the IRA. So, as a country, we're pivoting away a little bit from renewables and taking away some of those incentives, and maybe that'll drive additional gas turbine generation. Sure. The bill has tried to incentivize more nuclear build. As well, and there is some. The administration has also taken away some of the procedural hurdles to get new nuclear built. So maybe that's an avenue.
And the micro nuclear.
Yeah. SMRs is
right.
What we call them in the industry, small modular reactors,
mm-hmm.
where instead of a 1,000 or 1,200 megawatt generator, you're at a 150 to 250 megawatts.
Yeah.
So they can be built more quickly. The modular piece, ideally is you can build a whole bunch of them side by side if you want, or you can build them somewhere and then transport them to a location where they ultimately plug into the grid.
Now that technology is new to me. Is that new for people in the industry?
It's new kind of within the the civilian power generation space,
Okay.
but in the military,
Gotcha.
they've used the equivalent of small modular reactors for, I don't know, 60 years.
Yeah.
For our submarines and our carriers that are nuclear powered. It's a similar concept that's been morphed to be kind of used on land and for civilian use.
Right. And a lot of these data centers, that's one avenue they're pursuing.
The hyperscalers that build the data centers out are in my opinion, they're kind of doing everything they can.
Mm-hmm.
So they're looking for small modular because it's carbon free. They are revitalizing old nuclear plants that have been recently shut down.
Mm-hmm.
There's one in Michigan, one in Pennsylvania that are going to be restarted so that the hyperscalers can get power from them. But they're also trying to order gas turbines. You mentioned some of the constraints that we have. Currently, if you order a gas turbine from a GE or a Siemens or a Westinghouse, you probably are 5 years before you get it delivered.
Right.
And so there's a lot of challenges there. So they're also looking at solar and wind and anything that can get they can build the data center in 18 months, but if you can't get power to it, that doesn't help you very much.
Yeah.
So there's a lot of different, and there's, they're even looking at some of the older, call them dirty technologies, diesel generators,
right?
Just as an interim step that says, okay, we'll use that for 18 months to bridge the gap till we have a more permanent solution.
Yeah. I've heard some of the conversation kind of center around this idea. Yes, we may create more problems in the short term, but AI and things like that should lead to, or they have, some anticipation it will lead to breakthroughs to prevent some of the worst with the level of carbon emissions, et cetera. I'm curious, what are your thoughts on that?
There's a whole lot that goes into the CO2 emissions that we have as a world. We have to look worldwide around that. And so it's not as simple as moving from a coal plant to a gas plant or from a gas plant to a wind plant. So is AI going to help us create opportunity to streamline the grid? I think so.
Right.
One of the challenges that on the transmission side that we have is that you have to rate your lines for a certain amount of power that they can carry in any given moment. And most utilities do that in the most conservative fashion possible. So they take the worst case scenario day and say, that is our capacity on that line all the time. FERC is trying to move the utilities to do real-time ratings of the line, because maybe today isn't that worst case scenario day, and you can carry 10% or even up to 30% more power than that worst case day. If we can do more of that, then it doesn't matter that the construction delays are as long as they are, because we can get more out of the infrastructure we already have.
Yeah. And I wonder, with what is considered a worst case day, is that based on history? Because it looks like worst case can change. I mean, looking at the grid in Texas a few years back, did that exceed what they perceived as worst case scenario?
So the worst case scenario on the ratings of the line is based on ambient conditions.
Okay.
So when it's a really hot day, that triggers more sag in the line, which creates issues around how much power you can carry before you sag so much that you break the line.
Interesting.
Or you sag so that you're into a tree. Those kinds of issues. So that tends to be for that topic what I was talking about when I was talking about worst case scenario. From a overall grid perspective, and Texas was the one you were mentioning. They're a standalone grid, not interconnected with the rest of the United States, and so their modeling did not take into account some of the issues that happened during Storm Uri, and in particular, what they didn't take into account for was that the gas that comes out of the gas fields in West Texas and feeds many of the gas turbine plants would get frozen in. They couldn't get the gas out of the gas field and feed it to the power plants, so then the power plants couldn't run. It was more like, hey, if we lose, the X number of the largest generators on the system, what happens? But it didn't say.
The assumption was we'd be able to get the gas
to the plants that we needed to,
right?
And we couldn't.
Yeah. talking with Nancy, we looked at, what these AI robotics pieces of hardware will enable us to be able to do. And it seems like the level to which they can collect data and it be consistent data, the different sensors you can equip these robots with, we're going to have a better understanding of what's going on at some of these plants. We talked about, even with people, there's bias. You look at a building the same time every day, you don't necessarily see how it's degrading over time. Whereas robotics, they're not going to have those biases. Right. There's many levels of prediction there that we need to have. It seems like the best thing we can do now is just collect data and continue to make things more resilient as possible.
Yep. Yeah. And I think that what our partnership with Gecko will allow us to do, outside of just the robots itself, is to figure out what to do with the data we collect. There are millions and millions of data points that we have across our portfolio, and the vast majority of that data we do nothing with. And because the volume is so high, you're collecting
it's a lot to comb through.
It's a lot to comb through. So, you could probably never hire enough people to get through all that data and to make it useful.
Yeah.
But that's where I'm excited about this partnership, because with the right AI tool, taught the right way by seasoned power engineers, the tool itself can analyze those millions and millions of data points and tell us things that we just never could see on our own.
Right.
And we can also say, hey, this is data that we're missing, that we need. So we need to install a new sensor here. We need to send the robot, into this confined space that we'd never send a human into. Right. Those kind of things will come out of the data and data collection, I think. So I'm really excited about what that future could look like.
Yeah. And if problems do happen, that data is accessible. They could go back and see, this is something we need to look out for that may have seemed innocuous at the time.
Yep, exactly. And hopefully it can, the AI model can figure out things that wouldn't trigger an alarm within the control system, but things that are interrelated that cause problems that we otherwise wouldn't be able to predict.
Yeah. In my time using AI, my perception is that the software is very advanced as it is. And really what we're trying to catch up with is getting the data that we need and then understanding how to process that and then activate, robotics or other things.
Yep.
Is that your perception? It seems like there's a lot of training from now until then, that there's that data that we haven't tracked, but we have access to, given the technologies that we're involved with managing. There's a lot of potential for what we could do.
Yeah, and so I think, obviously, what we see on the commercial side available, through the chat GPTs and things of that nature, those large language models have been taught on general information available kind of on the internet, the encyclopedia of all things,
sure.
Let's say.
Collective consciousness.
Yeah, exactly. And I think what's missing from those tools is the very detailed analytics.
The boring stuff.
Yeah, exactly.
The stuff nobody wants to track.
Yeah, most people don't want to track. Most people aren't interested in what that output's going to be anyway.
Climbing up the stairs, taking a thermal image of the, right. Whatever it is.
Yeah, exactly.
Every single day.
Yep.
For 2 years.
Yeah.
And it wasn't until, day 165 that, this thing finally degraded to this point is causing this issue.
Right, exactly. And so I think that's where the training, as you mentioned, really needs to deepen for it to be successful within a technical environment.
Like so we're kind of pioneers.
About. Yeah, I think so. I think this is a pioneering partnership. I mean, it's really exciting.
We're a tech company now, huh?
We'll do our best to pretend like we are, yeah.
Yeah. Well, don't replace me with a robot, if at all possible.
Not planning on it.
All right. With this new legislation, it's changing how we're going to transition to electric vehicles. From my perspective, it's a foregone conclusion that we will as time goes on. What are the roadblocks in the way of that?
Yeah. So first, let me say I agree with you. I think it's a matter of when, not if. And there'll always be a mix, I think, of internal combustion and electric vehicles, for different use cases.
There are some now that have, full gas engine as well as electric, depending on if you're road tripping or otherwise.
Yes, exactly. And so that may continue as well. But I do think that most consumer vehicles eventually over time will be electric. There are other countries that have done more in the electrification of transportation space than we have so far. And particularly in China, they are building out thousands and thousands more vehicles than we are right now that are, from what I understand and what I've seen, nicer, cheaper, and get the same kind of range as what we're used to. And so,
the CEO of Ford, he said he's been driving BYD's top tier model the last few months and doesn't want to give it up.
Really, I hadn't heard.
He openly said that.
Yeah,
and just the reality is they're ahead of us.
Yeah,
by quite a bit in the electric car space.
Yep. Yeah, and so so I think that's coming. I think that with as a larger percentage of our vehicles become electrified, there is the opportunity to use them as a kind of battery backup to the grid, particularly in states that have high solar penetration. California always comes to mind because in California the price of power during the middle of the day most days is negative because there's so much solar on the grid. But if you can use that to charge your electric vehicle, and then at 6 o'clock when the sun goes down, and that's kind of also the peak load time when the commercial buildings are still using power, but people are starting to turn their air conditioners on at home.
Right.
And use it to bridge that gap from kind of 6 to 8 p.m. And then recharge your car at night too. I think there's a lot of value in that. The utility in the state of Vermont had started to use that. It's a very small state, has less solar penetration, but they have partnered with some of their customers to allow them to use the car battery to discharge into the grid, just as an experiment.
Right.
And it seems to be working well for them. Early days, I think they're 90 days into this, but
at scale, it makes a lot of sense.
Exactly.
My understanding is that it's the average household, it's about 4 days worth of power with the average car battery. And that's pretty good.
Yeah.
And every American family, has 1-2 cars or so, 1, 2, 3 cars. That energy during the day, in my head, I see these vehicles, maybe they're plugged in, and that power then just goes from the car to the grid as needed. Whether that be at night when there's not the solar farms gathering a lot of power, but a very distributed way to store energy that might be pretty effective.
Yeah. There are challenges with that. Our infrastructure was built with an expectation there'd be less load on the grid at night, and so the transformers that you see on the poles near your house, those cool off during the nights typically, and that allows the longevity of the transformers to be extended beyond their typical life. And if we move to a world which would probably be better for all, but where we're kind of the generation and load use are more even, those transformers will have to be replaced more often. So there's things we'll have to take into account from a maintenance perspective. Very doable, but just it will shift how our utilities have planned maintenance over the last, call it 100 years.
Yeah, companies like DeepSeek are working to really optimize AI, and the initial reaction was maybe we won't need as much energy as we thought, because these algorithms can be so heavily optimized that they're just not using the energy that we anticipated. In my opinion, and I'm just a marketing guy, but in my opinion, I think we're going to use up as much as we have to use. As much bandwidth as there is, we're going to use it, because there's going to be a day where we just start walking around with augmented reality glasses and AI helping us with everything.
Right. And ecoskeletons to help us move.
Exactly. You're on the same wavelength.
Exactly. I can jump really high with my exoskeleton.
Yeah, right. So. How's that going to change sports, Alan?
Exactly.
I want a 60-inch vertical if possible.
Exactly.
I'm 6'5", but I can't jump that high.
Yeah. So no, I agree. I think that, certainly as we've seen in the computing industry for decades, there'll be significant improvements in efficiency, how much power it takes to get what type of output, but we'll just find more ways to use the power that we have. And so I agree with what you're saying, that I'm sure that with efficiency, maybe the data centers don't use as much as we planned or we think they will today, but our exoskeletons will end up using all of that.
Yeah, I think, you have a surplus, you tend to spend a little more,
Right.
And I think with energy likely will be the same thing.
Yeah.
We have a little breathing room here. Why don't we start putting AI into our toilets, So
maybe they're already doing that in Japan. Their toilets in Japan are pretty amazing.
I've heard. Yeah. AI has certainly affected, high school students, and we're wondering if we're in an age past writing papers and doing homework. But I wonder, in kind of the industrial sphere, things move more slowly. How are things being integrated? Where are we at? How far are we away from, this stuff being fully optimized?
It is a challenge, I think. And part of the challenge, as I mentioned earlier, is the amount of data that is available and how to digest that. Another part of the challenge is the security risk associated with if this data were to get out. If the consolidated works of Shakespeare, get out, who cares? But if one of our nuclear power plants, all that data associated with that plant were to kind of get out onto the web, that could be a real risk. So, industrial is definitely, in the power sector particularly, is going to move a lot slower and a lot more cautiously for those types of reasons. I think that we're, still less than a decade, more than a year out from having the AI models be really effectively driving innovation within at least our industrial space in the power sector.
If we have robotics and AI are more effective in decreasing the amount of labor that goes into it, making things more efficient, things could get cheaper.
Yeah, the cost model for utilities, is an interesting one, especially for the IOUs that are what most folks interact with, the Southern companies and the PG&Es and these kind of companies. Their rate of returns are capped at a certain percentage based on the state public utility commission's guidelines. And so, but all of their costs are covered by you and me and everybody that pays an electric bill. So if we can use AI or robotics to drive down the cost of generation, or as I was mentioning earlier, this not having to build as much infrastructure because we can maximize the utilization of what we already have, we could see our personal bills come down as a result of AI. The competing thought in my mind is that, but we have so much growth that we have to overcome, and that's going to cost money. So I don't know. I don't know that I would predict a decrease in residential or commercial or industrial power.
We'll need
prices.
The efficiency increase.
Right, exactly. It's certainly possible.
Yeah.
Especially if we move, and maybe this is decades out, but if we move to more renewables, the wind and the sun are free. unlike gas or coal. And so that could drive down the overall cost to generate power.
I think humans need to learn to photosynthesize. I think we'd be in a better place. The sun is free.
Well, I mean, we could use, what is that, CRISPR technology?
Yeah, now we're talking.
To program fetuses to be able to do that. I don't know.
Oh,
Blend
man.
it with, splice in plants.
Yeah. If only we evolved from trees.
There you go. Exactly.
Things would be different.
Exactly.
Alan, thanks for coming today and talking. Energy is always evolving. It's a very dynamic industry, and appreciate your insight.
Yeah. Well, thanks for the good questions, and hopefully I'll be able to come back.
Yeah, absolutely.